Okay, so good afternoon or good morning, or so depending on where you are, and thank you for being here. So this is most possibly a 5 or 6 session course on just introduction in R. So uh, the aim of the course is essentially that it's a foundational course, and what it will allow you to have is to have some kind of independence in data analysis and plotting. Yeah, and by independence, what we mean to say is that you will know about an open source software, so you won't have to pay uh, or get a proprietary software for any kind of data analysis or plotting. So we'll use R. It works on all operating systems. It's free of cost. And the other thing is that you should be, at the end of the course, be able to perform your analysis and understand what is going on, at least to some extent, right? So it won't be hidden underneath in a black box or something like that. So that's the whole aim of the course. um, so at the end of the course, what we hope is that you can make plots like these. So for example, these are bar plots, and they show a distribution of something called sepal width. I mean, that's just an observation that we have made. And on these bar plots, we have also plotted these jitter plots or the exact data points. So we hope that at the end of the course, this is something that you can do by yourself. Additionally, you see that the points are actually a bit transparent. So we want you to have complete control. So we want you to be able to manipulate these parameters in plotting, and also to do the statistical analysis. For example, here we have done ANOVA, and also after that pairwise comparison to identify what is the difference significant or not, right? And then we have plotted it directly on the plot. So this would be the goal of the course, that after 5 or 6 sessions, this is the place where we reach, right? And just to also tell you what is not covered in this course. So what we do not cover is bioinformatics analysis. So we do not uh, go into gene expression or how to use R for bioinformatics. It's a very powerful tool for bioinformatics, but that is something that we do not cover in this course. We have a follow-up course planned for bioinformatics, but here what we are trying to do is to build up the basics for R programming. So we won't be going into specific expertise, right? What we will also not be do what we'll also not do is to actually code a new algorithm. So if you have a new problem or a new kind of analysis that you think would be useful to you, we won't be coding that in this course. So in here, what we'll be using are tools which are already available, which are already present in the community, and we'll be learning how to use them uh, to make simple plots, to make simple data analysis, right? And the third thing is that, of course, we are tackling with computational problems, and there are multiple ways of getting the same result. So you can uh, tailor the method to your needs. So depending on whether you want more speed or whether you need less space. So all of these methods have different compromises, but we won't be covering that. We'll cover a single method, or at max 2 different methods, to achieve the same result. And then we hope that you further explore the different possibilities by yourself. We'll tell you a few of the possibilities, but then it depends on you to go forward, right? And the timeline of the course, so how the course will go on. So it will be around about 2 sessions per week, and each of the sessions will be approximately 1 to 2 hours. So this is also the first time that we are actually doing such a course. So this is an approximation that we have, and we'll see how fast or slow we go, right? And after each session, there is an exercise that will be assigned. You can call it a homework or anything. And this is possibly the most important part of the course, because practice is the only thing that will make your programming better. So uh, just looking at YouTube videos and just seeing other people's code is not the best way to go forward. You have to take a problem and learn how to tackle it yourself. So this assignment or this kind of exercise will take approximately 30 minutes to 2 hours of your time. So but it's the most important part of this course. So this would be something that you'll have to do voluntarily. So your total commitment will be around 3 to 5 hours per week, yeah, to finish this course. As I said, the videos will be on YouTube. So if you think that you want to go slowly, you might want to see the videos later. And also you can email me if something is not clear, or in the chat write something. Yeah, so it's completely fine to go at your own pace, right? So with that, we can actually start the first session. That was just the introduction, and now we can start playing with R. Yeah, so the first thing that you'll see is in the preparation, we asked you to install R, and then we also asked you to install RStudio. So what is RStudio? So R is a programming language, it's used to code some algorithm, but RStudio makes the whole experience of coding and programming much more easier, and to be honest, a bit more enjoyable as well. So you will see that your RStudio window has these uh, parts, four partitions. And the first partition that we look into is this console. And this is where the code is being executed. So this is where any command that you type or anything that you type gets run, right? So this is the heart of the R programming. So also how the videos will be conducted is that I will be doing live coding. So that would mean that I will be actually talking about something and at the same time coding with you. So if you want, you can code along with me, and I'll try to be at a speed where you can do the coding alongside me. Or if you want, then you can listen to the videos and then later on code yourself. But uh, writing your own, like writing the code yourself and then practicing it yourself, is going to be critical, yeah, for learning any programming language. So we'll go to this console, and I have just zoomed in here so that you guys can see. You don't need to zoom in, right? And if you see here, you see this sign, the greater than sign, and a blinking cursor. So this is where any command that you type, R will execute it. I mean, if it runs into an error, if it cannot execute it properly, it will give you an error, but it will try to execute it. So we can type a simple command. We can use R as a calculator. So you can just type 2 plus 2, right? And when you type 2 plus 2, R makes the addition and then gives you the result. So you can see that the result is 4, right? And you can do any mathematical operation in this place. So it doesn't matter. Mathematical operations are simply things which will use plus, minus, multiply, division, right? And these mathematical operations, as you see, R just gives you the result, right? It doesn't really do anything else with it. But that is, we don't just want to use R as a calculator. We want to do more complicated things, right? And some of the complicated things is that we want to write R programs. So how do we write the R programs? And these programs are saved in this place, the top left place, which is called the editor. So here, where you see, where you have your R files. And the first thing here that we'll do is we'll set your working directory. So the working directory will be the place where by default your R program will be saved. By default, your plots will be saved. So that's your just default working directory. And if you don't set it, then sometimes it can happen that you save your R file and your output in a place in a directory which you don't remember. So best is to at least know which directory you're working in. So we'll set it by going to session. We click on session, set working directory, and then choose directory. And that will allow you to set your current working directory. So that's your default directory. Right? So I've just chosen this directory. You can choose anywhere on your computer where you want. You just need to have access to that directory. Yeah. And once you have your directory ready, we'll go and open a new R file. So we can say file, new file, R script, right? And it opens a blank space here. You can also open it through by this position, or the shortcut on Mac is Command Shift N. So all of these things will work to open a new directory, a new R file. So in the R file, whatever you write, you can save it as a file for later onwards, right? But it does not get executed. So it's just for archival purposes. Yeah. So if we write 2 plus 2, it does not get executed until we run this line of code. And the way to do it is to just press this run button. And then you will see that whatever is written on the line gets transferred to the console and is run, right? So you will see that the result of 2 plus 2 come here because it was run. A shortcut for running the code on Mac is Command Enter. So Command Enter will do the same. Or you can go to code and you can say run selected lines, and whatever is the shortcut here, that's just a good shortcut to learn. It will help you a lot because this is something that you will be doing a lot, right? And now let's save this file. So we can say we save the current document and we'll save it. So April 0, what's the date today? 04. Okay, so 04. So another thing that you'll see is that when you save the file, this .r was added to the file. So this is the normal nomenclature for an R file. They always end up with .r. So it tells RStudio that it's a normal R file, right? And this thing now you can open it, you can close it right now. So let's just close it right now. And we can, when we open it again, you'll see that whatever you have written there remains, right? So this is where your editing will happen, where you can save your file and you can have it, right? So this is the console that will run the code, and this is the R file. Now another portion which is really useful is this history. So on the right, top right corner, this part has your environment. We'll come to that, and your history. And history is really nice because it has a record of all the commands that you have run in reverse chronological order. So at the end, you have the latest command that you ran, right? So, maybe a few, like 5 minutes earlier, you ran something that you really wanted to run again. Then you don't have to type it again. You don't have to remember it again. You just go here. If you want to run it again, just say to console, and it will transfer this command to the console. So you don't have to type it again, right? And then you press enter and it runs, right? If you want to make a record of it, for example, maybe you didn't type it, then you just come here, click on the command, say to source, yeah, and it will transfer this this thing that you ran earlier into your R file, right? So to console will take it to the console, to source will take it to the file, yeah. So this is a really useful feature because you can go back as much as you want, and you can even save your history. So that way it will remember everything that you have done in the order that you did it, yeah. And the last part is this lower right corner, which shows, most of the time it's mostly useful to see the plots. So anything that you have plotted, any graph that you plotted comes up here. So we'll just make a very simple plot to just see how this thing works. So we'll just make a plot, just write plot, PLOT, just normal letters, round bracket and 1. And then we run the command either with the button here or command enter, right? And you will see that a plot comes down here. And in this plot, you'll see that it's only 1 point. We'll come back to why, how this plot is made and how can we define what kind of plot it will be. But you can, of course, zoom the plot to have it in a bigger size. Yeah. And also you can save the plot as an image or as a PDF. And remember, the default directory where the plot will be saved will be the directory which is your working directory. right? And that's why it's good to set it up, because this is where by default everything gets saved. So we can just say first plot. Yeah. And if you save view plot after saving, then after you save the plot, you'll actually see it. Another thing is you can change the dimensions of the plot. If you want to maintain the ratio, the width to height ratio, then you say maintain aspect ratio, and you can change it as much as you want. So if you change one of the parameters, the other one changes automatically. Yeah. So once you save it, right, and then it will show the plot. I don't know if you'll see it because it actually goes out of the R screen, RStudio screen, but if you do it, you'll see the plot. Yeah? So these are the four parts of RStudio. So you have your the file, the console, the history, and then the plotting location. Yeah, and this is something which makes it the whole experience of coding much more easier, because it's not like you're running the code at one place and then looking at the plots, going into the directory, then opening the plots and manipulating them. Everything is integrated. So that's why it's also called an IDE, integrated developmental environment. Yeah. So here you see that you have written all the codes, but they are difficult to uh, comprehend. I mean, they are difficult. It might be difficult after a week when you look at this file again to really understand why you wrote these commands, right? And to make notes for yourself, there is a really nice feature which is called comments. So you can make comments which are lines which are not executed, but they help you understand what you wanted to do in the code. So to write a comment, it's very simple. Just put a hashtag, and then anything written on the same line after that is a comment. It's not run, so it's completely ignored by the program. So you can write anything. For example, we can write here command to write our first plot, and then we can make as many commands as you want. So using R for simple calculations. And you can see that the color also changes, so it becomes green in color. Yeah. It's not a restriction to put just one hash key. It doesn't matter how many you put. Anything after the first one is ignored. So anything after the first one is essentially redundant, because it's not the R console completely ignores it. Yeah. And even if you are on a command line and if you run it, so let's run this line, you see that it will just print it out, but then completely ignore it. It doesn't do anything. It goes to the next line, runs it, and gives us the result, right? But for understandable code and mostly for readable code, it's very, very important to make a lot of comments, because you write a code today, and then after half a year, if you want to look at it, or if you want to share it with some collaborator, somebody else, then the only way you will remember or they'll understand the code is that if you have comments. It makes code writing much more accessible. Yeah. So it's very good to make these comments there, right? So now we did use R for making simple calculations, but you see that every time we wanted to get the result of 2 plus 2, we were typing it again and again. We were redoing it every time, right? So there was no memory. It was forgotten, and we had to retype 2 plus 2 again to get the result. What we can do is we can save the result of 2 plus 2 into a variable. Yeah. And how do we assign the value to a variable in R is very simply, we have a variable name. In this case, I've just put the variable name as a, and a equals 2 plus 2. So what this means is that the result of 2 plus 2 will get assigned to a variable by the name a. Yeah. And let's run this thing. Yeah. So you'll see what happened is when we run it, it goes to the console. Yeah. And now what we see is that we do not see the result. First thing is that we do not see what is the result of the operation. So we do not know what is 2 plus 2. But instead of showing us the result, it has stored the value of the result into the variable named a. And this this means that you have also defined a new variable, you have defined a new quantity, and this is then shown in your environment. Because this variable has become part of your environment, you can call it again, you can refer to its value again and again in future, right? So it becomes part of your environment, and this is something that you see right here, right next to the history tab, right? So you see the a and you see its value. But sometimes you want to look at the value of the variable, so you very simply have to just type the name of the variable and then run that command, and it will show you its value. Yeah. So now, whenever we want to know, or whenever we want to use the result of 2 plus 2, we don't have to type 2 plus 2 again. We have to never type it. All we have to do is to type a. And let's say if we wanted to know the result of 2 plus 2 plus 2, right? Then simply what we do is we do a plus 2, right? This equates to 2 plus 2 plus 2, right? Because a is 2 plus 2, right? And another thing, sorry, I forgot to tell you that you can also put a comment on the same line where you're writing the code. So it doesn't need to be on an independent line. Only thing is, anything written after the hash key is completely ignored. So you can, this is completely fine. You can write half a line as your code and then start a comment, right? So now we don't have to type 2 plus 2. So we do that and then we get the result as 6, right? So this is the use of a variable. It allows us to remember previous computations, and it allows us to use them or carry them forward to future for future analysis. Now, one note that I want to make is that this a, it's a variable name and it's completely okay, but it's a very, very bad choice of a variable name. So never name your variables in in a way that is not understandable, right? um, because and in future you will completely, or at least to me it happens that I can never remember what a meant or what kind of operation was it saving, right? So I'm going to rename this variable 2 plus 2, yeah, so that I can remember in future that 2 plus 2 was is this thing, yeah. And it's always better to define your variables in in explanatory form, so that later onwards you you just read the variable name and at least have some idea as to what kind of operation it was saving, yeah. So another thing that R likes to do is that or R doesn't like to do, in fact, is that it doesn't like to use this equal to sign when assigning values to variable. So we did it here and it's completely fine. It works. But what it likes to use to assign values is called an assignment operator. And this assignment operator is essentially an arrow. So this arrow tells us, like for example, we say 2 plus 2, arrow 2 plus 2. So what this arrow tells us is that you want to assign the result of this operation to this variable. And you can either type these two symbols, or a shortcut for this in Mac is Alt minus. So if you just type Alt minus, it will make this symbol on Mac. Yeah. So let's make another variable called mySum. So mySum has the sum of 4 plus 5. Yeah. So you'll see that we could define a new variable called mySum, and it's storing the value of the result of 4 plus 5, right? And I'll just quickly try to explain why people do not like to use the equal to sign, but instead like to use the assignment operator. And the reason for this is, now let's say I want to change um, the value of this variable called my sum. So my sum is right now 9, but I want to change the value. And now I want to put the value, let's say I want to put 2 plus 5, right? So now the new value of my sum will become 7, which is okay. But if I write like this, both of these lines will accomplish the same goal. They will change the value of this variable my sum from 9 to 7. But in this case, it looks like, just for a person who is not very aware of coding, or to a normal like when you look at it as a math code, it looks like what we are trying to say is that 9 equals 7. It just looks like that. It doesn't happen like that. This equal to is this equal to sign in R coding is not equals. It's not the mathematical equals. There is another mathematical equals, and later in the session we'll go to what is the mathematical equals. But just to the normal eye, what this looks like is we are saying is 9 equals to 7. But essentially what we are saying is assign the value of 2 plus 5 to this variable my sum. Yeah. So people were not very happy with this kind of notation, and that's why in R the convention is to use the assignment operator like this, because this is very simple. It means assign the value of whatever is happening on the right hand side to whatever is on the left hand side. Yeah. So this is the convention. So, and this means essentially assign right to left. And the interesting thing about the assignment operator is that it works both ways. And if you see, then the value of my sum has not changed. That's because I have not run these two code. So I'll run it, and you see the value of the variable my sum has now changed to 7. Right? And let me just go back. So if I want to run a previous command, either I can go to the history and run a previous command, or I can go to console and just press that up button. So up button also takes you to the previous commands, right? So I'm just pressing the up button. So I'm going to change the value of my sum again. I'll make it 9. And then let's run this line of code, which says my sum equals 2 plus 5, but it's not the mathematical equals, right? And it again gets assigned the value 7. So both of these lines are completely equivalent to each other. They do the exact same job. But just this thing looks much more meaningful. It's much more readable. Yeah. And the assignment operator works in both directions. So what this means is that we can have, let's say, 3 plus 9, and we can invert the assignment operator. Right? And this is also completely fine. Yeah. So this will just mean to assign the value, or whatever, to assign the value of the operation that's happening on the left hand side to something that's happening on the right hand side. Yeah. So you'll see that the result of my sum has now become 12. So this is completely fine. And this also makes it much more clear, because here the equal sign doesn't really have a direction. So it can become sometimes confusing whether you want to assign value from left to right or from right to left, but here it's completely clear. In this way, you want to assign the value from right to left, and in this way from left to right, right? And the assignment operator is also recursive, yeah, or inductive. And that means that we can have my sum 1, just another variable, and we can have my sum 2, and this will have the value of 5 plus 10, let's say. So what this would mean is that R will assign the value of 5 plus 10 first to my sum 2, and then it will assign the value of my sum 2 to my sum 1, right? And this is inductive, right? So you can have as many as you want happening, And you'll see when you run this code, you get two new variables, mysum1 and mysum2, and both of them have the exact same value. Yeah. So this is the inductive part of assignment. And I would also just mention to you one additional thing about the assignment operator, which you might see in some other people's code, but I don't really advise it. So I don't advise to code like this because it's not very easy to read. So let's make new one. So you could also do like this. This is completely fine. Okay? So what this would mean is that you take the result of the operation that's happening here. Because of this assignment operator, it gets assigned to mysum3, and because of this assignment operator, it gets assigned to mysum4. This is completely fine. It's not an error. It will run, right, and it will do exactly the same thing as this line of code, but it's not very easy to read. You have different directions of assignment operators on the same line. It's just something that not good practice while coding. Yeah, so it's not an advisable thing, but it's completely fine. You can have the directions of assignment operator change on the same line. Yeah. So this is the assignment operator, right? And it allows you to, as we said, it allows you to remember uh, an operation that you did, so you don't have to type it again and again. It stores the value. It becomes part of your environment, so you can call it anytime. To see the result of a variable, very simply, just type the name of that variable. Yeah. Another thing is that when you're typing the name of the variable, R will give you suggestions for completion. And many times it's good to wait, to either wait for R to give you suggestions or to put or to push the tab button. So the tab button will tell R, well, I need some suggestions for auto completion. And why it's a good practice to let R autocomplete the name of the variables rather than you typing them out is that it's much less prone to an error. Because if the R autocompletes it, then it will always autocomplete with the correct spelling, the correct name, because names are case sensitive. So we have a variable called my, capital SUM, right? So we will get the result. But if we, let's say, not capitalize S, so if we just say my small sum, then it will give you an error because it will say, well, there is no variable called mysum. Or if you leave it half incomplete, right, then also it will not. So these kind of errors, especially when you're coding a lot, can happen quite commonly. So it's always a good idea to let R autocomplete things for you. So if you just wait, then R will give you suggestions. You can choose one of the suggestions and then you can leave it like that. This auto completion also happens in the editor. It's not only restricted to the console. So let's also try it here. So we have and then you just press tab and it will give you different options for auto completion. Yeah, and it's always good to use this kind of opportunity rather than typing it yourself. Right? So this becomes, yeah. To look at the name, to see the value of a variable, type the name and just run the command, right, to get value. And as you can see already, we have defined so many mysums that it's now impossible to tell what is what, right? And this is another reason why, if you have very explanatory names of variables like 2 plus 2, then it's much more easier to keep track. For example, right now I have no idea how these different numbers came. Like literally, it's kind of impossible to keep a track of my sum 1, 2, 3, 4, right? Whereas 2 plus 2, well, it's explanatory what kind of value it has, right? So um, so never assign very generic names to variables. Make them explanatory. There is no restriction to how long the name can be, but try to keep it as concise as possible. Yeah, and use the assignment operator to assign values to variables, right? So this was very simple operations that we are doing, right? So we are just doing one operation and then saving its value into a variable. And in this case, you see that the variable only has a single number, and these variables are also called scalar. So variables that just have a single either a number or anything that is only one, right? They are called scalars. But you do not, most of the time you just don't want to have one number or just one result, but you want to have a collection. So you want to group a few numbers together, or we'll see a few characters together. And these things in R are called vectors. So vectors are just a collection of data. Yeah? So when you want to just combine data together, you want to collect them together, then what you generate are called vectors. Technically, scalars are also vectors because they are vectors of length 1, right? They have only one value, so they have value 1. So they are also a collection of data, but the data is only a single uh, of single value, right? But we can store multiple values. So let's say we define a vector, my number, yeah, and we want to assign it, let's just say six different numbers. So how do we define that? Is that we have to tell R that we want to store a collection inside of this name, inside of this variable name, and to say it, you just have to say C, then round brackets, right? So C means concatenation, combine, or collection, however you want to call it, it doesn't matter. But it will store a group of some data set, or a collection of some data set together into this variable, right? And so let's just make it so we can now put more than one data. I'm just putting random numbers. You can also do like that. You don't have to have the same numbers or even the same um, amount of numbers. You can do more, less. It's also fine to have negative. It doesn't matter. Yeah, they can also be repeated. But when you run this command, right, then you'll see that you have a new variable by the name my number. Yeah, and it says that it has number, and then it says 1 2 colon 9. What this means is that it has 9 numbers inside of it. So it's a collection of 9 unique value 9 values, sorry, not unique, just 9 numerical values, right? And we'll come back to what is the importance of this numbering 1 to 9. We'll come back to that, but right now we'll just focus on this collection of numbers. So the advantage of having this collection of numbers is that when you do an operation on these numbers, it happens simultaneously to all of them and also independently. So let's say if we want to add 1 everything, right? So we want to add 1 to all the numbers. Once you do that, you'll see that the result that you get is the addition of 1 to each and every number individually. Yes. And another thing that you will see is that when you see the result, you do not you do not get the comma in between the individual values that are stored. Yeah. So the result always skips the comma. So any blank means that it's the next number, yeah, in the vector, right? So 3 is the first number, blank, then 4 second number, blank, 5 third number, yeah. So this comma is missing. The comma is only when you want to define the vector, yeah, you separate them with commas. And this is also true for any operation that you do. So sorry, I wanted to write my number, we can multiply it by, let's say, 2, right? And this will double the value of every number here, yeah. So 2 becomes 4, 3 becomes 6, and so on and so on, right? So this is how a collection of data set is defined in R. Yeah. So using this function, and we'll also come to functions. So using this function called C, which stands for concatenation or combine or collection. Yeah. So first you will have to write C, then round brackets, then anything that you write in the middle, separated by commas, they become part of a vector, and in the vector they are all treated as individual values. Right. So this is a numerical vector because it stores numbers, right? We can also store non-numerical things. So right now what I'll show you is three other kind of vectors that you can define in R, or essentially they are universal to all programming languages. And the second kind of vector that you can have is a character vector. So in a character vector you have letters, right? You do not have numbers, you have letters. So let us define that. So let's say my cars. So this will have characters. So again, because this has to be a character vector, um, it has to be a vector. So that means it's a collection. So you have to put C. And to have characters, it has to be enclosed in double quote, either single or double quotation mark. It doesn't matter, single or double, but it has to be enclosed in quotation mark. Why? Because any alphabets without quotation marks, R treats them as names of a variable. Yeah. So for example, here these are also made up of letters, English letters, but you see there is no quotation mark. And if you write anything without a quotation mark, R will treat it as a variable name. Whereas if you enclose things with quotation mark, R treats them as characters, as English characters. Yeah. So we can say ABC, right? And then let's say BCD, it doesn't matter, MNO, XYZ. Yeah. So when we run this, then you'll see that you have defined a new variable, and you will see that it's doesn't say that it's a number anymore, but it's a collection of characters. And it's a collection of 4 characters because we asked it to store 4 independent values separated by commas, right? And now this variable has this such a collection. And as I said, that R considers names without quotations as variable names. So let's see what happens when we do something like this. So we tell R that we need a collection of my cars without quotation mark, right? This would mean that it's the name of a variable. Then we need a collection of this along with let's say D, E, F. Right? So can you imagine what will happen? What R will do is that it will make a collection of the variable name my characters, which in itself is a collection of 4 different uh, character scalars along with DEF. Right? So at the end of the day, what you'll get is a collection of 5 characters, right? The first 4 being my cars, the variable, the characters which belong to the variable my cars, and the last one being DEF. Yeah. So this is another way how you can also add more values to an existing vector, right? So you just have to put them in a bracket, um, in C bracket, name of the variable, and then you can add anything. You can also add something at the front. Yeah. So if we do like this, right, then we have asked R to make a combination of DEF and then the variable my cars, right, or my character, which is a combination of 4 different characters. Yeah. So at the end of the day, you get a 5 um, a vector with 5 different values, which starts with DEF and then goes on to have the values defined by my cars variable. Yeah, you can store the value. So mycars1 in a new one, and then this mycars1 is now a vector with 5 different values, def, followed by the values in mycars, right? So this way you can make a combination of numbers, a combination of numbers, a combination of characters. You can add new quantities to an existing vector, and you can store the value of these new quantities into new vectors, right? Giving them new possibilities. This thing will also work for numerical vector. It works for any vector. I didn't show it to you above, but let's do that. So just for sake of completion, so if we add my number, and let's say we add a few more values here. Yeah. So let's just run this line. So you see, you get all the values of my number, and you follow it up by the 3 additional values that you added, right? So so this is how R is making a collection of numbers and characters in one-dimensional form. So all of these are one-dimensional properties, right? They only have a collection of, they are not two-dimensional in the sense they only have a linear collection, right? Then the third kind of vector, which is very, very useful, is a logical vector. And a logical vector is very simple because it's a result of a logical operation. So an operation is when you manipulate something, right? So for example, 2 plus 2, the plus is an operation you're adding. So it's the addition operation. A logical operation is comparison. So greater than, less than, equals to. Yeah. So these, at least these 3 operations, then what you get is a logical vector. And a logical vector is really simple because it only has 2 values, one which is true and the other which is false. So if 4 greater than 3, well, the result is true, right? So that would be true. Is 4 greater than 5, then it's false, right? So you can only have 2 values for logical. Technically, you can have 3 values. You can have what is called a missing value, but we won't come to missing values right now. Yeah, missing values are when, let's say, if you compared 4 to infinity, right? Then you get 4 to infinity. You can compare, but let's say if you compare like infinity to infinity, then it becomes like a missing value. Yeah. So we won't do missing values today for this session. So just to simplify everything, logical vectors can only have 2 values, true and false. Yeah. So let's make a logical vector. So we'll say my logical is my number. Yeah, we take the numerical vector, and let's say we want to know which of these numbers are less than 15. Yeah. Uh, so all we have to do is say 15, right? So what R will do is it will take each number in this vector, it will compare it to 15, and then it will tell you whether the number was less than 15, well then it's a true, and whether the number was, if the number was not less than 15, then it would be false, right? So let's run it, and then let's see the result of the result of this comparison. Another thing that you'll see is that you will get a new vector here which it says logi, that is logical. Yeah. And the length of the logical vector will be exactly same as the length of the numerical vector, right? Because it is going to compare each and every number to 15, right? So the length will be exactly the same. So if there are 9 numbers in my number, then you will have 9 logical numbers, 9 logical values in my logical. Yeah. So when we do this, here you go. We can look at the values of my number again. The first value is 2. So 2 is less than 15, so it comes true. 3, 4, 5, 9. They are all less than 15, so they are 5 true. Then 15 is not less than 15, so you get a false. Similarly, for 24, 78, 98, they are all greater than 15, so you all get false values, right? So this becomes a logical vector, right? uh, the interesting thing about a logical vector is that underneath it's actually a numerical vector, and it's a numerical vector in the sense that the value of true is actually stored as a number 1, and the value of false is actually stored as a number 0. Yeah. And so what you can do is you can use it to get some information about the logical operation that you did. So I will come to functions in a little while, just quickly, but if you could just write sum and then double bracket, round bracket. So sum is an operation that will give you which will add up the numbers and just give you the result. So let's do sum of my numbers, my number. So this will give you the addition of all the numbers in the vector my number, right? So if you were to just sum up everything, so 2 plus 3 plus 4 plus 5 until uh, uh, 98, right? So this makes sense because my number is a vector of numbers and you can add them up. But similarly, you can add up logical vector. And as I said, a true in a logical vector is 1, a false is 0, right? And when you add it up, what you will have is the number of true values that you had in the logical vector. So this logical vector had 5 true values. So the sum of this logical vector should be 5, right? So this is just something to remember about logical vectors because it's very useful to at least get the amount of truth, let's say, after your comparison, uh, because every true is assigned as 1 and every false is assigned as 0. So you can just do a very simple sum and it works on this. Very importantly, something that I think I missed, you cannot do numerical operations on character vector, right? Which makes sense because a character, I mean, ABC plus 1 doesn't really make sense. So if you try to do that, it doesn't work with character vectors. So my cars plus 1, let's try to run it, and it will say that it's an error, right? Because my cars plus 1 doesn't really make any sense. There is nothing like ABC plus 1 or BCD plus 1. Yeah. So but for logical vectors, you can at least do some of the numerical operations. So you can at least do some. Yeah? And we'll come to other numerical operations with logical vectors, which we can do. Yeah. And the last kind of vector. So these are the 3 main vector formats that we have. I'll discuss one more. But just let me know if something is not understandable or something is fast, right? It's very simple. You have a variable which stores values. Either it can store a single value, like the result of a single operation, or it can store a group of values. And for a variable to store a group of values, it always has to be enclosed in a collection. Yeah. And there are 3 kinds of collections. You can have a collection of numbers, you can have a collection of characters, or you can have a collection of logics, so true or false. Yeah. The last thing is that you can also have a collection of which are separated by groups. So it's still a collection, but it's a collection that comes from predefined groups. So for example, if we take a bag of red, blue, and green balls, yeah, and within that bag of three different color balls, we remove them one by one, right? So we know that there are 3 different color groups, and we want to store this value. So then we can store this thing in what is a very nice feature in R, and this is called a factor vector. So factors just means groups, and how you will define them is, let's say, my factor, right? It's still a collection, so you have to make it C round bracket, right? So this will make a collection. And now let's say that we picked up balls from a red, blue, green. So the first ball was red. Sorry. We also have to enclose this whole thing in factor. So what this will tell us is that it's a collection of characters, but these characters belong to predefined groups. We don't have to define the groups. R will guess the groups by itself. It will see unique values and then it will guess the groups by itself. So let's just do it, right? So we tell R that it's a collection of variables which will become a factor. So it's red, green. Let's say the third one was red again. Then the fourth one was blue, right? And the last one was green, right? Now, when we run this, yeah, what you will see is you'll get a new variable called my factor. And now it says that it's a factor with 3 levels. Levels are the name of the groups. Yeah, and that's how R considers them. So levels are name of groups. And you already see that R actually guessed that it has 3 different levels, right? So red, green, and blue. Let's see if it did guess that. So when we look at the value of my factor, then it shows us the different characters that we made a collection of, as well as it shows us the levels. These levels are groups. So it thinks that there is a group called blue, there is a group called green, there is a group called red. Yeah, and this is very useful because most of the time you are using groups. Like for example, during when doing an experiment, you have a control group and a treatment group, right? So this is another layer on top of a character vector, right? Because when you have this character vector, like here, every element is independent. There is no relationship between them. They are just a collection of unique characters. But when you have a factor, they are also a collection of characters, but in that case there is some sort of organization in them, and it's just a good way to organize factors in terms of groupings, right? And this is a very powerful tool that you have in R and also in other coding languages, because it allows you to do many manipulations in a very fast manner, and we'll come to that I think in the next session, how do we use these things, right? But uh, this is one of the major difference between a factor and a character vector, that characters vectors do not have groups, whereas factors have groups. They are organized. Yeah, and you can again add new things to the factor. So let's say we found a new color. Let's say we got cyan, right? So now we want to combine this factor variable with a new one, right? Let's see what happens. You see, actually R made them into numbers, and we won't go into that. Um, there is a reason why it did things like this. So addition of new elements into a factor vector doesn't really work straightforward manner, and this is something that we'll go in the next session because it's a little bit intricate, and we'll come to that but a bit later, right? So handling these factors vectors are a little bit different than how you will handle the other ones. Yeah, and the reason, just quickly, the reason is because these factor vectors are actually used as numbers. So internally what R is storing is that blue is the number 1, green is number 2, and red is number 3. And so it actually thinks that internally how it is storing is that it's actually 3 2. So red as 3, green as 2, red as 3, blue as 1, and then 2. And it doesn't really store it as a character thing. To make it okay, we'll come to that later. Yeah. So just to make sure that addition of new elements is not similar to how it was for a numerical vector or a character vector. Yeah. So addition is not similar to other types. Just something to keep in mind. Yeah. So this is essentially how the basic collections of data types in R works. So there are, yeah, so there are 4 different data types. Okay, this is zoomed in. I'll just have to zoom out. Um, so how do we store data in R? We either store them as we actually always store them as vectors. Yeah. You can also have a vector with a single value, then it's called a scalar. But technically a scalar is a vector which only has one element. Yeah. And to make a collection, you have to use this nomenclature C, small c, and then a round box, and each element has to be separated by a comma. Yeah. And technically scalars are 0-dimensional because they are a single value. Vectors are 1-dimensional because they are a linear collection. Yeah. And there are 4 major types of vectors. So there is a numerical vector, which is a collection of numbers. There is a character vector, which is a collection of characters. Yeah. And this is something that I missed. So each element is also called a string. So each element of a character vector is also called a string. Yeah. So in this case, A is a string, B is the second string, C is the third string. Yeah. And the third one that actually we looked at was logical. So a collection of true or false conditions. And the fourth one is a factor, so grouping. So which is very similar to character in a way that it stores groups, although technically you can also have groupings of numbers, so you can also group unique numbers, no problem. Yeah. So it doesn't need to be character variable, but most of the time it is, and it's very useful for experimental work when you have drug control. So just think of it like different groups you want to put together, but internally the factor vector is stored as a numerical, so its behavior is slightly different. Yeah. So next thing that we have now stored values into vectors, right? But that's it, right? Most of the time we were stopping there. I mean, we made an addition on the numerical vector, but that's about it, right? But that's too superficial. That's not, that's so we want to be able to do more operations, and the way to do operations on anything, either vectors or scalars, is to use something called function. So a function is essentially a specific operation that you want to do, and the function connects an input, which is also called arguments of the function. So what do you give as the input to the function, to as an output. So it's a transformation. It's a it converts the input into output. So for example, technically the plus sign is a function because it's a function to add the numbers, right? So 2 plus 2 equals 4 means that the argument for the plus function is 2 and 2, so that's the input, and the output is 4, right? So technically any operation is a function. Yeah. And in R, how do you use functions is you have the name of the function, and then in bracket you have its argument. And actually, if you remember, then the C to combine different values together is also a function, right? And so the function C, this function here, right, it takes the argument 4 3 5, and its output is a collection of 4 3 5, right? So this was actually a function that we were using beforehand, right? So this is how all the functions in R are working. You have the name of the function, then you have your brackets, and inside it are the inputs or the arguments. Yeah. And you will get, when you call a function, so this is also called calling a function, when you execute it, you will get an output. Most of the time it will be an output, sometime it will be a plot, right? So it won't be a numerical output, or or an output that can be stored, right? So sometimes it will be a plot, but most of the time you get an output, and that output you can store into a variable. So actually you can store it, uh, just like using the assignment operator, right? And we look at a few functions. So we already looked at the function C, which combines them, and we also did the function sum, right, which adds things up. So then we look at a few more functions. But before going into functions, I want to talk about how do you know how to use a function, right? So like for sum, it's very simple, right? You do sum, and then you put some numbers in the middle, and it will give you the addition, right? So it's very simple. But most of the time it may not be so trivial as to what the input or the argument of a function will be, right? So to know that, it's very, very simple in R. All you have to do is to make a question mark and then write the name of the function without the bracket. When you execute that, it opens up a help page that tells you how to use that function. So it describes you, first thing, it will describe you what the function does. It will tell you how to use it. It will tell you what the inputs are. So inputs are also called arguments. Yeah. So it will tell you, okay, that the input to this function can be a numerical vector, it can be a logical vector, or well, complex vector, we leave it for now, right? So it can be a numerical or logical vector, right? So here we had also done the sum of a logical vector. So for logical vectors, true 1, false 0. Yeah. And then it will give you a few more details, and it will also tell you what the output will be. But best thing is that it will tell you it will give you a few examples, so it will tell you how to use them in certain cases. And this is really helpful because it allows you to get a hang of how the function is working, right? So this is one way how you can come to know how to use a certain function. But sometimes it might happen that you don't even know the name of the function, right? I mean, sum is easy, so it's easy to know, but how do you get a logarithm? Let's say we want to make a logarithm of this number. uh, I mean, I don't know what is the name of the function, right? Then what you can do is, there are two options, actually three options. The first option is you can Google. So Google will help you in these cases. You can type it here, you can type a word here, and it will search the help pages. Or the third way is that you do a double question mark. So a single question mark, name of the function, allows you to search by the name. A double question mark searches all the help pages. Sorry, too slow. Yeah. So the double question mark is going to search all the help pages. So let's do a search for logarithm. So it's going to take a little bit more time. And okay. And it's going to give us the functions or the help pages which had the word logarithm in them. And base just means base R. So functions that come when you just have the normal version of R. And uh, these are new packages. We'll go into packages later on, right? But you would want to essentially use the base function, sorry. Right? So this is one way in which if you do not know the name of the function, then you can search the help pages. Now, for some of you, it might happen that this thing did not work. The double question mark logarithm did not work. And that's actually a glitch in the old RStudio. So if that is happening, just upgrade your RStudio and this glitch goes away. Actually, the previous version of RStudio had some problem, so this double question mark is not working. Yeah, you can try to put logarithm here to search the help pages, but sometimes even that doesn't work. So if it's not working, it's not something that you got wrong. It's just an older version of RStudio. If you upgrade it, it goes away. Yeah. And so, well, now we see, okay, that there is a function from base R that allows us to do logarithms. And then we click on it, we see that the name of this function is log, right? So we didn't have to know the exact name of the function to search for it, right? So if you know the name, but you want to have more information, single question mark. If you don't know the name, double question mark. And of course, you can always Google. Yeah. So let's start with log, right? So let's read how to use it. So it says that to use log, we have 5 different options. We can either do a log to the base 10. So this kind of log here. We can do a log to the base 2, right? So it tells us here log 10 computes common logarithms and log 2 computes binary base 2, right? Or we can even do a natural log. So log to the base e, which is just simple log log. And we can also do a log to an r-bit base, to a base that we want, right? And it tells us what the arguments have to be. So the input x has to be a numerical vector, yeah, and the base, which is the second argument, so the first argument comma the second argument, it has to be a positive number. Let's ignore the complex for now. Yeah, it has to be a positive number which will become the base, right? And if we do not define a value of the base, then by default it will put it as e. So we'll go through this we'll go through all of this one by one, right? So let's first see what our number vector was. So if you have put negative numbers in your number vector, just define a new one which doesn't have negative numbers, because the log of a negative number, I think it should throw an error. Yeah. It will not throw an error, but it will put NaN, which is not a number. Yeah. Uh, so it's very similar to a missing value, but not really a missing value. It's just not a number. Yeah. So just remove all the negative numbers or define a new vector which only has positive numbers. Yeah. So when we look at this number vector, okay, we have all the positive numbers. Now let's take the log to the base 10. Okay. So let's see. So log to the base 10 only has one argument, x, where x is a numerical vector, right? So when you want to type the arguments to a function, you can do it 2 ways. The first way is go inside the round bracket and press tab. And when you press tab, it will actually suggest to you the arguments that it thinks you should place, right? So in this case, it suggests to us x equal to, where x is a numerical or complex vector. So all I did was went inside the round bracket and pressed tab. And if you press tab again, then it will print that argument. So x equal to, and then x equals to my number. Yeah. So it wants x to be a numerical vector, and my number is a numerical vector. So this is completely fine. So when we do it, it will give us the log of each of the numbers individually and log to the base 10, right? Similarly, you can do log to the base 2, right? Go inside, press tab, it will suggest to you the argument. Again, sorry. So now you get log to the base 2. And you can see actually the first value was 2. So log of 2 to the base 2 is 1, right? So you get the value 1 here, if it's not very visible, right? Whereas when you take log 10, it's less than 1, right? Now, the thing is, R allows you to match arguments by position. And what that means is you do not have to explicitly write x equal to. If you just give it an argument without specifying what it matches with, if you just give it an input without specifying what argument it matches to, it will match by position. So this is the first value that I have given. The first argument it wants is x. So it will just assign the first thing that I write here to x automatically. So you don't have to write x equal to. You can match by position. So this is matching your arguments by position. First input is first argument. This, you see, you get the exact same result as the previous one. Yeah, because it just matched my number with x. Yeah. So now we can also do to a different base. Let's do to the base 3. Yeah. So if we want to do logarithm to the base 3, then we do not have an option from these two, but we can use this one, right? So it's log to a base that we can define, right? So if we do log b, so we need to use this function. We make the circular bracket and then we give the input. So you have to put, you can press tab. It will suggest what arguments to give. So x equal to my number, right? And the second argument it needs is base. You also see here with base, it says that it has a default value. So if I do not define base, then the default value will be exponential. So technically, to use this function, I do not have to define the value of base. It will just, R will just put its value as exponential. But we don't need exponential. We want the value 3. So we actually define it. Base equals to 3. Yeah. And now we get logarithm to the base 3. And now you see that my number had the value 3 in it. So log of 3 to the base 3 is 1, right? So initially it was doing base 2 and now it's doing base 3. Yeah. So we have changed the base. Now again, we can match our inputs by position. So again, we will do this. And when we match by position, sorry, we won't have to specify the arguments. So we can do log b. We can just put my number and then 3, right? Now what R will do is the first input, it will assign to the first argument that it wants, which will be x. The second input, it will assign to the second argument that it wants, which is base. So this is just match by position, right? This is now, you see, giving the exact same result as before. We didn't have to say base equal to 3. Now, this is completely fine, but again, I would not advise it. I would advise always to specify which argument is getting what as an input. Not only because it avoids errors, so there is much less scope of error here, but also because this is much more readable. Because here, to know what is happening to this 3, actually you will have to look at the help pages of this function called log p, and only then will you understand, okay, this 3 means base 3, right? So without, just by looking at this, until and unless you really know what log b stands for, there is, it will be very difficult to know what this number 3 here is doing, right? So it's completely fine to code like this, but it's not an advisable way of writing code. It's better to do like this. Another thing is, if your code is going too long and you want to make it more and more readable, because actually making the code readable is a very important part of coding, because you are not the only one who will be reading your code, other people will. And also it's very easy to forget how your own code. Yeah. So if you think that it's going very long, after a comma you can press an enter to just make it continue to the next line, and you will see that the R will already make an indentation, and it puts it right beneath the same argument, the arguments for the same function, right? So this here means that it's a continuation of this same function, and we are just assigning more and more arguments. So if you think that your line is just going too long, just press enter after comma and it comes to the next line. It still behaves exactly the same way, so the behavior doesn't change. Yeah. And this is a much better way to write. Another thing is that when you match an input by the name of the argument, the position doesn't matter. So what I mean is that it's completely fine to first define the base. Even though it says here that it's the second argument, it's completely fine because you are defining by name, right? So R will assign this number to this argument. It wouldn't care if it's coming first or second, it doesn't matter. And then you can define X equal to my number. Right? So this is also completely viable way of doing it. Your result will remain exactly the same. So when you are matching your input to your argument by name, the position will not matter. The position only matters when you do not write the name of the argument. Yeah. Last thing is that R also allows you to do what is called partial matching. And that means that if you have multiple arguments, then you can just write a part of their name. Also, I wouldn't really advise it to do that, but R allows you to do that. So instead of typing the full base, you can also do B equal to 3. As long as the arguments have unique starting start, so that R can specify which argument is which. Yeah, it can. It's unique, so it doesn't really clash with each other. It will allow this. Yeah. So the result is exactly the same. So we didn't have to write base as completely because there is no other argument that starts with B, right? So you can make it shorter, but also again, it's difficult to read. It's not very intuitive what is going on here until and unless you know what log p stands for. So it's for me, it has always been that this is the best way of writing code. Yeah. Writing a longer code is not anything bad. Yeah. The code has to be readable and understandable. Yeah. So this is the different ways of using a function, of calling a function, and how a function happens. Another thing is, right now we were just uh, calling a function, but the output was being displayed here, right? We can always save it. My docs, right? So we can always make a new variable, log e x equal to my number. Now the output is not shown on the console. Instead, it's saved in a new variable. Okay? So you see, you do not see any output here below. But if you call, then you see the output. Okay? So just to go through the functions once more. So functions allow you to do specific operations. right? Uh, to learn about how to use a function, use question mark, name of the function. If you don't know the name, you can Google it, or try to do a double question mark and then something that relates to the function, right? And to invoke a function, you need to call the name followed by a round bracket, and within the round bracket, you need to put your arguments, or you need to assign values to arguments. And the way to assign values to argument, the best way is to write the name of the argument equal to what value it will get assigned. Yeah. So in this case, you see, we do not use the assignment operator, because in this case we know that this is the name of the argument, and it will always and this is the value that will be assigned to it. So in this case, it's always right to left. Yeah. And within the function, it's conventional to use equal sign, whereas when you assign values to a variable, it's conventional to use the assignment operator. Yeah. But within a function, it's always the equal sign that's being used. Yeah. So if you have multiple arguments to assign, you can separate them with a comma. You call them by their name. The uh, the position of the names do not matter. You can call first argument. You can put arguments in an order which is not put here, so it's completely fine, as long as you put the name correctly. Yeah. And some of the arguments also have a default. So if you do not assign value to them, the function will still run. It will use the default values. But if an argument has no default value, then you have to assign some value to it. So for example, if we do log b, so x has no default value, right? So if we leave the value and just say base equal to 3, right, it will give us an error. Yeah. Because it will tell us that this x, which has no default value, it has to have something for the function to run, right? So if the default value is defined, you can skip it and it will use the default value. If the default value is not defined, then it has to be assigned to something, right? Otherwise it will throw an error. Yeah. So this was how to use a function in the most basic sense. We'll just go through a few other functions that are really, really useful, which may or may not do a specific operation but help you. So one of the function is mode, right? And what the function mode does is it will tell you the type of vector you have. So for example, if we do mode my number, then it tells us that this is a numerical vector. Yeah. And if this is not very clear, well, then just question mark mode. Right? So you'll get the help page, and it says get or set the type of storage mode of an operator. So storage mode means just what kind of values are stored in it, right? And it will give you some examples, like um, for example here, it gives some examples which are a little bit complicated actually, right? But in the very simple way, mode allows you to know about your vector, and this is sometimes helpful because uh, maybe it's not very clear what was actually stored in the vector sometimes. So this is something that you can use. So for character vector, mode tells you that it's a character. For logical vector, it tells you that it's a logical vector. And for factor vector, remember we talked that factor vectors are actually stored as numbers, where every group is a unique number. So this is the reason why a factor vector is actually thought of as a numerical vector, right? Even though If you go and look into the environment, it will say a factor with 3 levels, but internally it's stored as a numerical, right? So factors are numericals, considered as numerical. Um, right? So this is a really helpful function because sometimes it allows you to understand some variables, or in some cases it also allows you to understand the output, right? Because one thing that you can also do is to just do an operation. So let's say mod 2 plus 2, and what it will tell you is what kind of output will I get from this operation, right? So if we do mod 2 plus 2, then it tells us numeric. So what that means is that the result of 2 plus 2, whatever the result will be, it will be a numerical result, right? If we do mod, let's say 2 greater than 3, right? So in this case, it will not give us the result, but it will tell you what type of result we will get, right? So it tells us that the result will be a logical result, right? So it sometimes helps in this way, uh, to know beforehand what kind of result you are expecting, so you can manipulate the result a bit better. Yeah. And let me just go through the notes. Yes. Yes. So the next function that we can talk about is related to factors. Just very quickly, a few things, a few ways of looking at factors. So let's just look at my factor. Okay. So my factor was a factor variable. It was a collection of different of the different names of colors, but they were essentially grouped into uh, three different colors, right? Blue, green, red. And a few things related to factor vectors which are really really helpful is that one thing is you can get a table for my factor, and this function table, it, as it suggests, what it does is it will give you how many elements per group exist in your vector. Yeah. So if we run this, you'll see that it very nicely tells you that the group blue has one element in your vector. So there is only one blue, right? There are two green, so two times, and then there are two reds. Yeah. So this is a very useful function for factors. In counting, it allows you very quick counting of different things, right? And another function that I think is really really useful is length. So length, as the name suggests, will tell you how many elements does a vector have, right? So get or set the length of vectors or factors. Yeah. So you can see an example here. For example, a few examples are given here, but we can use it here. So we can do length of my factor. Yeah, we just have it here. So my factor has 5 elements, right? So its length will be 5, right? So it has 3 groups, but it has 5 distinct elements. Yeah. You can also have length of any kind of vector. They are all one dimensional. So in one dimensional vectors, anything with length will work. So for example, my number. Okay? So there are 9 numbers in the vector called my number, right? And similarly, this length works for character vectors. So there are 4 characters in the vector my cars, right? Now, uh, I'll give you one exercise and then I'll just wait for 2 minutes. So let's say if you have a factor variable here, right? And you have, which has 3 groups, and you know what is the number in each group. could you make an operation to find out the proportion of each group within the full vector? So we need the proportion. So like there are 5 elements, but so there is 1 by 5 blue, there are 2 by 5 greens, and 2 by 5 red, right? So how can we get the proportions for each group in a factor? Yeah. So I'll just wait for 30 seconds. If you want to think about it, how can it be done? Uh, just a hint is to combine length and table together. So if you combine them together in a way, then you will be able to get proportions, right? So if you want to pause, you can do that, because you can continue later on, right? But one way would be to make a table, right? This table will give you how many elements belong to each group, and if you divide it by the length, by the output of the length of your my factor, right? So the length is going to give you the total number of elements, right? Then you should be able to get the proportions, right? So let's see if we actually get that, right? So 1 by 5, so zero point 0.2, then 2 by 5, zero point 0.4, and 2 by 5, zero point 0.4, right? So you can combine these functions to get new information about your data, right? And this is one strong point of why having a factor vector is very useful, right? It was very easy to get the proportions out, right? This allows us to do that, right? To calculate these things in a very quick manner, right? Okay. uh, Regarding numbers, I mean, the base R has a lot of uh, operations that allows you to get more properties about numbers, right? So like sum is going to give you the sum, the addition. Then there is you can also get the average by using this function called mean, right? So this gives you average. So this will be the sum divided by the numbers, the number of elements, right? So let's check if that is the case. So if we want to check that, then we will do sum of my number divided by length of my number, right? So this would be the average, right? You take the sum and then you divide it by the number of elements that this vector has, right? So that would be the average, right? So let's see. So it matches the average, yeah, right? So right, but there is a simple function to do that. That's called the mean. Yeah. And you are more than welcome to explore more and more functions. I mean, of course, the more you practice, the more functions you will learn. So this will give you the sum of all numbers. This will give you the average, right? And there is a function called square root, SQRT, which gives you the square root of all the numbers individually, right? So this is just explanation of a few ones, but yeah. So one last exercise before we move on to the next topic, which we will very shortly cover, and then we will the next session is completely on that topic, but I'll just quickly move on to that topic to give you a little bit of introduction, uh, so that for the next time at least we have some we have it's primed, so we can start with the next topic very quickly. Yeah, but just before that, let's do one last exercise. So we had this vector called mylogical, right, which had 5 logicals and 5 true and 4 false. Now let's say I want to know the percentage of success or true in this logical vector. So again, 30 seconds, maybe you can think of it. Right. So success of true would be, um, what is the percentage of true would be number of trues divided by the total number, right? The total number of elements, right? So, and just remember that true is 1. So if you make a sum over mylogical, then you get the total number of true. Yeah. And I'll just write down here, but if you want, you can pause it so that when you have thought it out, then you can write it down. Right. So when you make a sum, then you get the total number of trues, and the length will give you the total number of elements, right? And if you just want to have a proportion, then it's fine to make a division. But let's say if we really want to have a percentage, we can multiply this by 100. So we can multiply this number by 100, right? And we get that 55.56% of all the values here are true, right? Which should be 5 divided by 9, right? So let's do that. 5 divided by 9. So multiplied by 100, so it's 55%, right? So as you can see, when you combine different functions, you can get more information about them. You can get proportions, these kind of things, right? So um, before proceeding, actually, I forgot one thing. So I'm going to just talk about this. Since we are at logical vectors, and I remembered, is how to invert a logical vector. And inversion means to make opposite, right? So the opposite of true is false, and how you do that is by using the exclamation mark. So this is the operation for invert, right? So this equals invert. So exclamation mark true equals false, and exclamation mark false right? So let's do that. So we can see the mylogical here. So let's do exclamation mark mylogical. So you see, everywhere where it was true, it now has become false. So every true becomes false, and every false becomes true. So this is just the way to invert a logical operator, a logical vector, right? A very simple way. Just exclamation mark, right? And this thing you can also type. So because true is also a vector, so you can actually type and see. So exclamation mark true will be false, right? Um, Another thing about the style of coding is do not give your variable names similar to existing operations. So don't name a variable true, because it will make a conflict with um, this logical value true. So never do something like this. True equals to 4 greater than 5. I mean, I actually do not even know if R will allow it. Yeah, it doesn't even allow it, but I would say not even to make it like this, TRU equals 4 greater than 5. It's better to give them names which are not very similar to existing operators in R. So this is also not a good practice to do. Okay. So the last thing, very shortly, is subsetting, which is most possibly the most important part of data analysis or data manipulation. And so actually the next two sessions are completely on subsetting. So it's only 10 to 15 minutes today, and then the full next two sessions. And subsetting is a very important concept, which essentially means that you want to select or extract some values from a vector. So either you want to select, we'll go through them. So you either want to select some values based on some condition, or you want to extract a part of the vector, you want to extract a smaller part of the vector, right? And subsetting always is done by the square bracket. So it would be nice to know for you to see on your keyboard how to type this square bracket, because it's a very common thing in R, right? So for a function, when you want the arguments, they are round brackets. But when you want to subset, when you want to extract some values from a vector, then you have these round brackets, right? And this is a concept that I'll introduce today, that subsetting can be positional or it can be conditional, and we'll go them into much more detail next time, but we'll just start off with this thing, right? So first of all, we'll go to positional subsetting, right? So as I said, all vectors are one dimensional objects, right? So vectors are one dimensional, and what it means also is that they have position, or they have positional information, which means that for a vector, you know what is on position number 1, position number 2, position number 3, 4, 5, 6, and so on and so on. And actually, if you pay attention to how R is printing your output, you will see this positional information. So R writes this number 1 here, which means that it has started to print the vector from the first position. And you will also notice that whenever the output is given in 2 lines or in multiple lines, it again prints the position which belongs to the element which is first printed on the next line, right? So this is position number 1, 2, 3, 4, 5, 6, 7. So 7th position, 8 and 9. Yeah. So in R, for all the vectors, positions always start with 1. And if a few of you have experience with C or C++, their positions in vectors started with 0, but in R, that's not the case. So in R, the positions will always start with 1. So the first element is 1. Yeah. So here again, the first, second, third, fourth, fifth, sixth position, right? And what this allows us is to get extract elements based on their position. So let's say if we want to have the value of the first element, or the value which is at the first position, right? So how do we do it? We write the name of the vector, very simple. Then we want the first position. That means we want to subset it. We want a smaller set of the whole collection, right? That's subsetting, a smaller set of the whole collection, right? So we make square brackets and 1. So this would be the first position. Okay. If you are, if it's if the typing of, if you don't want to type the comments, it's okay, because whatever I do here, I'll share as an R file. So if you are just typing the command but not typing the comments, it's fine, yeah, because this all will be shared. Yeah. So let's get the first element. So the first element of my number, it says, is 2, right? So let's see if that is correct. Yes. So the first element is 2, right? Let's see if we want to have the third element. The third element is 4. Now let's say we want to have the first, third, and the fifth element, right? So we want to have a collection, a smaller collection of this bigger collection, right? So we again say my number, and we want the first, third, and fifth, a collection of first, third, and fourth. A collection is always given with C, right? 1, 3, and 5. So this tells us we want the position number 1, position number 3, and position number 5. Yeah, let's see. So we get 2, 4, and 9. Right? Sorry. We can also make it a range, and this will also explain why here it says 1 double colon 4, because in R a range is defined as it is defined with colon. So if you have a number, let's say x colon y, that means give me all the numbers between x and y included. Give me all numbers from x to y, right? So let's see. So let's say 1, 2, 3. So 1 double colon 3 gives us 1, 2, and 3, right? And this is something that you can use for subsetting. So let's say if we want the first 5 values, so first 5, then you can go to the vector my number. You want the first 5 value, so you want to subset, you want a smaller set, right? And you can do 1 to 5. You don't have to write C, because the thing is the result of this operation, actually this 1 double colon 5 is an operation, right? It gives the result as a vector, right? So the result of 1 double colon 5 is actually C 1 2 3 4 5. It's just a shorthand way of writing C 1 2 3 4 5. So this is just something that R will do for you in the background, right? So this is completely fine, and it's exactly same as doing 5 or writing C 1 2 3 4 and 5. Yeah, they are all three the same. So this tells us that we need the first 5 elements. So we get 2, 3, 4, 5, 9, which are the first 5, which are at the first 5 positions, right? So now another exercise. So I'll leave some time, or you can pause. What if I want the last element of a vector? What kind of subsetting will allow me to do that? I just want the last element, without knowing without putting a number. Yeah. So just the hint is that you can use length function to get the length of the vector, right? Which is a number that corresponds to the last element, right? So if the vector has 9 elements, then the function length gives you the number 9, right? So if you want, you can pause it, but to get the last element, right? So you can combine this function length, and if you do length of my number, right? So length of my number, this operation is going to give you the length of this vector, which is also the last position in the vector, right? And then you subset it, right? And when you do that, you get the last element, right? Right? Because length of my number is equals to 9, is how long the vector is. Another thing is this subsetting and range works in any direction. So the position need not be in ascending order. It can be in any order that you want, right? So let's do it here. So we can also do my number. Let's say we want, for some reason, we want the third element to be put first, then the first, and then the fifth. Yeah. So we want to shuffle them around a bit. This is completely fine as long as you give it a legal or a defined position. It will give you that number in that order, in the order you want it, right? So if we see what my number was, so here we get 3, 1, 5. So the third position, first position, fifth position. So the third position is 4, first is 2, and the fifth is 9, right? And similarly for range, right? So let us do it here. So let's say we want the first 5 numbers, but we want them to be in the opposite order. So we want them to go from 5 to 1. So very simple, we just say 5 to 1, right? And then we will get them in the opposite order, right? Because 5 to 1 equates to 5, 4, 3, 2, 1, right? So position number 5, 4, 3, 2, and 1. So you can also use this to invert a full vector. So to put it um, in the opposite direction, right? Because you can do length. This will give you the last position. And if you go from the last position to the first position, then essentially you have inverted the order. So you have put the last element first, then second last, third last, fourth last, and going until the first, right? So this will be an inversion. Invert the vector. If this is too fast, then it's completely fine, because this is just a primer to subsetting, and we will go through the whole subsetting thing in much more detail for the next 2 sessions. So just try to follow as much as possible. And when you practice, because of the assignment, you will see that it will become more clear. Okay? So the next thing is that you can also do a negative subsetting. So here we were asking for which elements we want. We can also tell R which elements we don't want. So for example, if we do not want the first element, so we don't want the first element, then a very simple way to write is to just say -1. So minus the position. It's much more better to always write it like this, when you, especially when you do negative, because -1 looks like it will work, but it looks like the number at the position -1, right? And that doesn't make sense, because a vector always starts with uh, so this looks like, it's not, but it just looks like the element at position -1, right? So if you do that, you see, now we are missing the first element. It's only a vector of 8, of length 8, and the result is exactly the same as this, but this is just a bit easy to read, because what it means is to leave the first element, right? This is a bit more easy to read, whereas this can be confused with give me the number at position -1, which doesn't make sense. Yeah. Again, you can keep playing with this. So you can, let's say if you want to drop the first 5 elements, right? So this, so you just say 1 to 5 and you say minus, and that means I want to drop the first 5 elements. Okay. So this is positional subsetting. And here we either define a position, we either define the positions that we want, or we define the positions that we do not want. What we can also do is we can also do conditional subsetting. And in conditional subsetting, instead of giving it positions, we give it a logical vector. And in the logical vector, whatever is true is kept, whatever is false is removed. So we can do conditional subsetting. And this is done with the logical vector. Okay. So you have your vector, you want to subset it, and you subset it with the logical, right? And in this case, true positions are kept, false positions are removed. Very, very simple, right? Let's do that. So my number is a vector having 9 numbers, right? So let's say if we want to keep the first 5, so we can do true. Just copy paste it, 5, right? And then we can do false. So now we have given it a logical vector in which the first 5 elements are true, the last 4 are false. So now it's a conditional subsetting. So again, we get the first 5 vectors because only the first 5 elements were true. And you can play around with this, right? So you can, whatever you will keep as true, those positions are kept. Whatever you won't keep as true, those positions are not kept. Now, one thing that R does is that R can also recycle for, for this kind of subsetting. And what it means is that you do not need to, if you do not subset with a vector of length 9, where you actually define what happens to every position, then R will just reuse it iteratively. And so, for example, if you just do this, true, false, false, right? Now, my number is a vector which has 9 elements, but we are only subsetting with it with a logical vector which has 3 elements, right? So what will happen to the last 6? Because for the first 3 we have defined what we want. We want the first one, we don't want the third one, we don't want the second one, we don't want the third one. But what about the fourth one, fifth one, sixth one? What R will do is it will run over this thing in a cyclic manner. So it will do first, second, third, then 4, 5, 6, then 7, 8, 9. So you'll get the every fourth element, right? So you'll get the first element, then your second and third are dropped. You'll get the fourth, fifth, and sixth are dropped. You get the seventh, eighth, and ninth are dropped, right? So the first one is kept, second and third are dropped, the fourth one is kept, fifth, sixth are dropped, seventh one is kept, right? So you can also subset with vectors, logical vectors which are smaller in length. They will just be recycled. And here is where you have to be very careful, because if you give it a smaller vector which is logical, which doesn't really whose multiple doesn't really lead to the length of your original vector, R will still do recycling. Yeah. So for example, if our number is a vector of length 9, if we give it only a vector of 2, then it is okay. It will go for first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, and there is nothing for 10th because my number doesn't really have a 10th element. It will do it. It will only throw a warning telling you that it feels that something that you did not make complete sense. It's okay. I mean, this will give you all the odd number values, right? Because it will give you first, remove second, give you third. So first, third, fifth, seventh, ninth, it will give you. This is fine too. This is one way to get all the odd values, right, in a vector, right? So get all odd values, not positional values, right? Not all values, position values, right? But an R will do it. It will recycle, but it will tell you something is okay. It doesn't really give a warning here. Sometimes it does throw a warning if you do a recycling in which it's not a multiple, but you just have to be a bit careful, because this will lead to some loss of values, right? But anyhow, it's giving us all the odd values. Let's just change it because it should have thrown some kind of warning. Okay, doesn't throw any warning. Right. Okay, so this would also give you all the even values. So this is the concept of recycling, right? So first thing is you can subset with the logical vector, but you can also use smaller logical vectors to recycle. And this is a kind of trick uh, to get specific positions, right? So this is every fourth position, every odd position, every even position values. And the last thing for today is that you can use the logical vectors to subset, um, not just subset, but also to get values that specify a condition. Yeah. So let's say that you want all the values less than 20 from my number. So you want to extract all the values that are less than 20, right? So all those values are 2 to 15, right? And you want to extract them. You don't really want to just say, well, I want the first 6, because this vector my number can change, right? You want to write a general function of general operation that will do that, right? So how would this be possible? First, you can say is less than 20. So let us define a logical vector which just calculates if a number is less than 20 or not in this numerical vector, right? And how do we do that? We just say less than 20, right? So in this case, R will compare each and every value individually to 20 and tell us if the value is less than 20, it will tell us that it is, it will give us true, or it will give us false if it is not less than 20, right? So we have defined a logical vector which tells which positions are less than 20 and which positions are not less than 20. And now to get the values, we can very simply just use this concept and now subset the vector based on this new logical vector that we created, right? And the length of this logical vector is same as the numerical vector because each and every element was compared, right? And once we do that, we get all the numbers which are less than 20, right? You can, once you get used to this thing, you can do it a little bit in a shorthand way, right? So let's say if we want to have values less than 10, right? So you can say your vector, you want the values from this vector which are less than 10. So you want to subset it, and your subsetting is a condition based on whether or not the number is less than 10, right? So here we just specified this condition in a new logical vector, and then we use that logical vector for subsetting. So instead of doing this in a two-step manner, you can just do it in a one-step manner, right? So inside this subsetting, what is happening is a comparison is happening between each element of my number with 10. If the number is less than 10, then the position becomes true, and if the position becomes true, then it's subsetted and it's kept for later, right? So here you get the output in which all the numbers are less than 10. You can also do inversion. So what if I want all the values which are greater than or equal to 10, right? So that means I do not want the values which are less than 10. Okay. So all I need to do is put the invert sign, okay, and then this. Okay. So this is a comparison from less than 10. You want the opposite values. So you do the same comparison, but then you just invert it. All the true becomes false, all the false becomes true. And then it's again subsetting. So now you get all the values which were not less than 10, right? So values not less than 10. Okay. And that is it for subsetting for now. Um, so in the first exercise, you will have a revision on what are vectors and a few of the operations on vectors. And for that, actually, you'll have to install something, but the instructions are given in the first exercise on GitHub. And I can also email it. Uh, with that, I think um, with that, we'll have the next session on subsetting. And possibly we'll also go to two-dimensional data structures, because here we were just working with one-dimensional data structures, but we'll go to two-dimensional data structures, and we'll see also how subsetting works in that case. So the next two sessions, I think, will be all uh, a little bit more complex data structures and subsetting. Um, but just try to get practice subsetting as much as possible, because this is the most important concept in data analysis. Because many times you want to select a few values, you want to get the you want to extract a few values, and all of that is done by subsetting. So it's a very fundamental, very foundational thing, for which you need to develop good skills, right? And last thing, also develop good skills for writing readable codes. So the code has to be readable by you and by others. Put a lot of comments. Don't be afraid to have long codes. It's not a bad thing to write a long code, but it has to be readable, right? And so with that, thank you, and we'll see you next time. So the next session is on Monday, 3 p.m. GMT, uh, and I'll send an email or a message to everybody. Cool. Thank you. Bye bye.